Yep. Round of applause for KJ, everybody.
Okay.
5 minutes.
Today we have a chance to help Ethereum ecosystem because we want to do something like the first world computer with upgradable CPU. This will be a little friendly to all the people here, technical people here. But if you are still confusing, we're building the Windows for the blockchain, the operating system. Okay. Look at this. This is something I'm very familiar with. I'm very happy with. Just imagine the big coins like all the oldest PCs, right? Ethereum 286, and now our currently we are using their tools and centralized their ones. It's so sad today. After 20 years, everything becomes centralized. And to make a U-turn, let's use Zentra as the opportunity to go back to or suppress the Bitcoin's decentralization. That's the big map. Okay, so how do we do that? First is our today's product Zentra, and second one we are going to go beyond the decentralized Bitcoin with useful pure data. Okay, so we are coming from the theory. So for me, I'm a PhD in blockchain, in crypto and blockchain. So we have this minor theory, and it's here in Stanford. I presented the minor theory. Also, I have my PhD thesis. That's something else about the first useful POW. Okay, let's imagine about the older PC, family C, FC, and family computer, right? So basically, it's just like a very traditional way, like an application programming directly to the hardware, right? The application, the hardware. Like today, Uniswap is programming to EVM, and the Pump.fun is programming to Solana. So let's look at the history to predict the features. So someday in this world, it's not a long history, there will be something happened, like an operating system, like a DOS, like Windows, right? Something will happen, sure, for sure. Just look at the history. So what Zentra is doing, we're trying to create an ecosystem. You see, Ethereum's ecosystem, each layer 2 has their own ecosystem, but they are detached with their chain, right? Ecosystem is detached with chain. Ecosystem cannot move from chain to another chain. But a third-party ecosystem, Zentra, can do this. We are starting from the base layer 2. It provides 500 TPS space. Then Monad, as they said, they provide 10,000 TPS. So at certain days, we just move the Zentra, the ecosystem from base to Monad, and in the future, on another blockchain, say we are going to provide a huge TPS. So we move to that chain again. So the user assets will be staying Zentra. That user doesn't have to move their assets through the bridge from this chain to another chain. We get a stable environment, just like we are staying Windows for so many years, right? Okay, how do we do it? The traditional Ethereum node is tied together with their consensus mechanism with execution. They are tightly coupled. But in Zentra's architecture, we create a new word called sync blockchain. Is that we suggest blockchain should only record the history data, but not do the consensus, not do the execution. So what we are suggesting, in another word, we are suggesting the EVM chains to drop their EVM. Bye-bye. No, blockchain should be seen just to become
1 minute.
consensus machine. Okay. So what else can we do? More than just upgradable this feature, we are using Python on the blockchain. You can do smart contract programming with Python. And we don't have a gas limit. That means complex application can be programmed on Zentra, but which was impossible to do in the EVM. So that's unlimited execution time. Okay. So also what makes Zentra more decentralization is another case. We make it the Zentra node can be run on every personal device. That means we have limited the global we call it global state size. If you're running a Ethereum node now, you know how much hard drive, how big the spec you need. So you have only to run to the AWS to run the Ethereum node, right? But in Zentra, we try to limit the global size so every home device can run Zentra. Okay, that's how our decentralized come from. Okay. Yeah. Then the last question: Zentra will have token. What is this token used for? So we are going to use the Zentra token. Each Zentra token will stand for 1 kilobit, 1 KB on-chain space. If you scan the blockchain now, you will feel a lot of global space are trash tokens, right? People pay Ethereum just zero gas, but they occupy the on-chain space. But once it's not popular again, nobody will touch it again. So that's it. No, Zentra token is valuable, locked. Our stage, our testnet 3 is here. Our mainnet, hopefully we can do in this quarter or maybe next quarter. Okay. Thank you.
All right. Round of applause. Sir, you went over your time, so you're lucky you're the last presentation. Otherwise, there'll be a lot of angry people in here. I'm just kidding.
Yeah.
All right.
I'm not going to be the last one.
3 minutes for questions for KJ. First question.
Yeah. Thank you.
Does this type of chain design help you mitigate, say, like the upgrade from quantum resistant signatures? Like, let's say you wanted to increase the key size.
I love the quantum feature. Yeah. Last year I met a guy from PhD who is really doing the quantum physics experiment. The guy PhD. He just graduated, and once he graduates, suddenly he jumped into the crypto space. Never touch his quantum experiment again. So I will say, quantum. Of course, we have to be quantum resilience. That's good, and but I'm less worried about it. Okay, but I think in this architecture, one day we really have the quantum computer, right? We can soon change the maybe Ethereum wallet address or something, to a quantum resilience algorithm. Yeah.
Right. So, like, for example, you're saying you're decoupling the EVM from the actual block
Yeah.
itself. So, for example, if I want to increase like the byte length of addresses or resources that the EVM is using, is that like?
No. We just use the same Ethereum address. All the Ethereum wallet can be used. Yeah.
So it'll still be vulnerable to.
Yeah, ETH RPC, ETH address, we just incur. Because that's the industry standard. We don't change that part. No. We're not Solana. Okay. Yeah.
Next question. We have a gentleman over there in the orange shirt.
Okay. So one question: this is an entire new chain, correct?
No, it's very less change. We only change a very small part. We can work with all the existing ETH RPCs. Yeah.
Right, but it's an own separate chain where there is own stakeholders, its own.
No. We are not a chain. So we still use the layer 1 or layer 2.
technology
Yeah.
on top of
They do the concepts. The chain do the concepts, and I do the execution. It's like
Okay.
so the input we construction the state.
So as a wallet user, what do I have to use this technology? Like,
You go to the website. The website use Zentra. Then you can use the existing wallet to do some signature. Then everything is fine.
that actually feels. I feel more scared to do that because you just said I go to a website and sign signature. And
Yeah.
basically means like I
And then you can see what's
happening.
in your
It's very
what
scary
you are
for me.
signing. It's just a JSON. Very simple. Yeah.
All right, we're gonna go to Noah, and then we're gonna go to Jerry. Noah, do you have a question?
What's your probability that we're ever going to have quantum compute that can do useful things that's
You are talking about maybe the use for POW?
if we're ever going to have quantum that can do anything but cracking cryptography?
I mean, ECDSA is not quantum resilience, but hash is, SHA-2, SHA-3, they are quantum resilience. Yeah.
Jerry?
I was just wondering, how are you dealing with the order of these transactions coming in?
The transactions go to the blockchain first. We just read the blockchain. We just read the output. Yeah.
Right. But
Yeah.
for a lot of these chains, before like the transaction, sometimes it's like in the event pool before it gets processed. So a lot of the time, the EVM, depending on the order you're coming in, sometimes transactions can fail, sometimes they succeed.
We just read the outcome of the blockchain. So the frozen blockchain, the new blocks. So once the transaction go into the new blocks, they are frozen, right?
But nothing before they get into the block.
Of course, we need to wait for the blockchain to be final. Yeah.
Okay.
Yeah.
Because that's where most of the execution for a lot of these smart contracts, the DEX and whatnot.
We are doing a bit of asynchronized way. There's a bit of delay, but the trade-off is that we can run very complex applications in the virtual machine. Yeah, that's a trade-off. We lost something, but we got something better. Yeah.
Let's do a couple more questions. I feel like this is an engaging conversation. Now, while you were the first one, then we'll get the next one.
Is there like any decentralized compute applications possible? Have you tried anything else there?
We have one example demo. It's like with AI, it's like Ethereum come with trading ability, but only with after AMM algorithm, right? In this architecture, we can run all the book on chain. That's like a lot of comparing, a lot of like complex data structure we need to apply it in that way. In that way, we can run order book. Yeah,
Wouldn't you be running the order book? Like order books are already prevalent on so many L1s and L2s, like you mentioned.
Pardon?
So order books are already present on chain. So
No. Except the new one called what? Hyperliquid, right? Yeah.
Finally.
IBM?
Yeah, Hyperliquid. Yeah.
Okay, let's move to Borough.
But that's also not in VM. That's in chain, not in VM.
So what I'm understanding, you're a modular platform where you're separating the consensus and the execution? Or
Basically, the modular blockchain, they have a full definition, including the DA or whatever. We are maybe you think it's like modular, but our definition is different from modular. We are just say so we are same blockchain and the minus theme, something like that. It's like we are the same blockchain, only record the history and another part do the execution. We only have two roles. We are different from the modular blockchain. Yeah.
so who's doing the heavy lifting of like maintaining the state, and who's incentivized for that?
Maintaining the state is in Zentra. Yeah.
The EVM still?
EVM we bypass it. It's still existing, but we don't use it. It's like you can send your transaction to EVM, but you can choose not to send your transaction. But you only send a Zentra transaction, but you still send to base.
All right, folks, this is an engaging conversation. We can continue during the networking section. KJ, thank you so much for your presentation. It was engaging and
Yeah, thank you for your question. Yeah.